Hi, PoE people. Um, this is going to be just starting our introduction to building circuits using breadboards, which we do have physical breadboards to use in the classroom. However, we're going to use them virtually on a website called Tinkercad as well, and we're going to do that first. So I've got this handout that hopefully you've seen that I shared with you and you're looking at. And I'm just going to kind of cruise through it, but you may wonder where the name breadboard comes from, and the idea was that people used actual like cutting boards or breadboards for attaching their electrical components and creating circuits. All right, so the idea of a breadboard really comes from our modern day one, like finding an easy, helpful way to make your connection. So if you think about laying out your components, a battery, an LED, a resistor, just a simple little circuit, you're going to have to connect the battery to the LED. You're going to have a little wire, and you've got to make a connection, right? So how are you going to make that connection? Well, these are just some common ways, right? You can solder things. You could kind of twist the wires together and then heat and melt solder, which then it'll cool and harden to make a pretty, it's semi-permanent. You can unsolder things, but that's kind of a more permanent connection intended to be. You could twist the wires together and then try to help keep them from untwisting. You can use things called wire nuts. You can use little wire connector pieces. And maybe more in our scheme, like something that's quick and simple would be kind of clipping on and off. So your wires having these little alligator clips on the ends. That would be a way to prototype a little circuit pretty quickly. And I've got some of those in the classroom too, and those work. So, but a modern breadboard today gives us a way to kind of plug and unplug our components and to have them be held and be making connections to other things. And so there's just a picture of a breadboard. Here's an awesome website you can go check out called Adafruit. I've linked to a whole slideshow, or not slideshow, but kind of a series of pages you'll kind of click through to get a lot of little pictures. These two little pictures did come from this series of little pages that talk to you about breadboards and how they're used and introduced you to them. I really strongly suggest you kind of at least skim through that and take, even if it's just 3 or 4 minutes, skim through it and just kind of see. You'll get more pictures and explanations. But basically you have all these little metal strips, okay, underneath the plastic that, when you poke a wire down through one of those little holes in this plastic thing, it's actually going into one of these little kind of metal teeth or prongs that are kind of squeezing together. There's gives the ability for the wire to kind of go in between two little fingers that want to touch and stay together. So they have some springiness to them, right? They open up a little bit to allow the wire in, but then when you pull the wire back out, they kind of snap back together. And all these little fingers or things are connected by one common piece of metal. They're all one unit, right? So you plug two wires into the same two different little fingers or clips, but part of the same long strip, and you've in essence connected them together through this is now this kind of acts as a conductor or like a wire, if you will, to make that connection. So this is what's happening underneath the breadboard. Now there's a lot of these strips. It's not one plug in any one hole here and you plug in any others, right? And all wires are connected. We need to be able to make all different little connections. And so we need to understand the pattern of how a breadboard is laid out. So we are going to use Tinkercad, and these are some snips from being inside Tinkercad that make it really easy for you. If you highlight, this is just showing that if I highlight and put my mouse over the breadboard, so that little red dot shows where my mouse was, the whole row that represents one long metal clip. So each of these holes along that where it's highlighted green are all connected. So if you plug a wire in any one of these holes and another wire in any of the other ones, you've in essence connected those two wires, just like you would have connected them had you soldered them together, okay, or twisted them together. It's just the breadboard's going to hold them. And so we've got some really long runs, okay, in this orientation, the top and bottom have two really long rows, okay, those two on top, those two on bottom. Sometimes people refer to those as like buses. Just gives you kind of a really long strip that you can provide power and ground, and get power and ground across kind of the whole length of the breadboard pretty quickly. And so if you go back to maybe to this picture, you've got all these little black things are called ICs or integrated chips, and they all need power and ground. And if you've got power and ground running along the whole long strips, it's just easy to bring power and ground to them more efficiently, more cleanly with little wires, kind of these little yellow wires right there, kind of going towards the chip. There's one here and then one up here. This yellow one right here and this one here are probably providing power and ground to that little IC. And so that kind of helps. But then on the interior, you see a lot of, a lot more holes. And I put my mouse over one hole, and you see that it's a column in this orientation. You've got 5 little holes that are all together. So each of these little strips and columns right now, again in this orientation, these are columns. So I can rotate it, and then they'd be rows. But each of these is its own little metal set of clips underneath. Okay, and then these here are also other sets of 5. Notice the green does not continue across the middle. There's like a channel, little break in the middle, and that's really intentional for those ICs we were just mentioning, that they have a place to plug in. They've got usually pins on both sides, and they can plug in without connecting. We don't want to actually connect any 2 pins on the same IC together unintentionally. Maybe intentionally we would, but then we would use wires going from one set of holes to the next to kind of make an intentional connection. So if you plop an IC down across this channel, every pin is connected to its own little column, either on the top or on the bottom. But because this set of 5 is disconnected from this set of 5, kind of each one has its own little set of holes that we can then make connections to the IC with. Now in our class, we're not going to really be working on the logic and things that come with using ICs. However, it's good for you just to kind of be, introduced and have those seeds planted in your mind of kind of why that's there. So our focus is really going to be just getting used to this basic layout of a breadboard, creating our basic circuit types of series and parallel, using the multimeter to measure our measurements for, kind of circuit analysis of voltage, current, and resistance to confirm those relationships that we went over when we did the circuit analysis equations. Okay, so we're going to launch you into Tinkercad and let you start playing around. I've got these steps here. So I do have other tabs. I think the screen's getting cut off, but I have some other tabs where I'm going to go to tinkercad.com, and I didn't have that prepped. Forgive me. Let me go ahead and log out so you can see what it looks like when you come in. So you're going to come to tinkercad.com, and if you've never logged into Tinkercad at all, you may have to hit join now instead of sign in. And if you hit join now, we're not really setting up a classroom for this, so you can go ahead and use the create personal account, but then sign in with Google. So as long as you're in Chrome and you're using your school, account, that'd be great. And I think even though I'm already signed in, if I just click that, it just signs me in and recognizes me. I don't really even have to worry about that. I hit the join now instead of sign in. So it's going to find my account. Okay, once you're logged in to the main page over here, Tinkercad is also used for 3D modeling. You have to click on circuits over on the left. Okay, and then to start a new circuit, you're going to hit this little button, create new circuit. You may get little reminders and things, or just suggestions if it's your first time in. All right, so we're going to start bringing in some of these basic components. To bring things in over on the left, you're just going to click, hold, and kind of drag it into the graphic window, and there you go. If you select an item, you can change the name, you can change the value. So like this resistor, right now it's on 1 kilo ohm. I can change it to, let's say, how about 250 ohms. So I can change the number. It's really cool that the little colors change. And I'm going to put it on ohms instead of kilo ohms. So we can bring resistors on. We can do that. We can also, if I right click, will it give me the suggestion to rotate? No, I have to hit R. Yeah, if you just hit R on your keyboard, it will rotate around as well. All right, so that is a resistor we're going to need. We're going to need LEDs. I'll just drag that on. We are going to need our breadboard. So let me go find a breadboard, drag that on. We are going to need a power supply, which we can use a 9-volt battery, but then it's always 9 volts. I'm going to go ahead and bring in a power supply by going to basic, right here, components, where it says basic, and I'm going to change that from basic to all. And I get a lot more options. I can go find things to pull in. Right now I just want to be super simple, so we're not going to really bring in much else, but I'm going to scroll down until I get to an area called instruments right here, and there is a power supply. I'm going to drag a power supply on, and I'm also going to grab a multimeter. That's something we can use to measure. Okay. All right. On the power supply, if I click on it, you see I get a dialog box where I can give the name. I can change the voltage, so I can play around with what volts I want, and the current, it's fine. don't think you'll have to mess with that for us. So voltage is set to 5. If we had a word problem that we wanted to match it up against that did say it was 9 volts or 12 volts or whatever, we can go in here and adjust that. Okay? All right, so let's think about making a series circuit and just making these connections. Okay, so red is my positive and black is my negative. To make wires and kind of connect to the power supply to here, you literally just move your mouse and hover over those points of contact where we're going to make connections, and it'll highlight, and you're going to click. Just click and let go your left mouse, and then you can start to move your mouse and you'll see what is going to be a wire. Now, if you go exactly where you want to connect, it just makes a straight wire, but you can make turns. So if I want to bend the wire, I can come kind of here and click once and then keep moving my mouse, and it'll create a point, kind of an anchor point there where I can create that bend. Okay, now after I finish making the wire is highlighted, it's selected right now, and I can also change the color. Now a cool keyboard shortcut is to know that these are kind of numbered, like 1, 2, 3, 4. So if I remember that, like if I want that to be red, if I just click that and then press 2 on my keyboard, so people that use Tinkercad a lot, they're kind of, I was like, how do they do that so fast? They change the colors. I didn't see their mouse going. I realized that they were just using their keyboard. And so black was 1, so they hit a 1 and like that. Pretty cool. So what I'm going to do is I'm going to bring my positive to the positive strip here, and I've got the negative to this one on the opposite side. And I'm going to work kind of across the breadboard just to make a loop. Remember, electricity's got to make a loop. All right. This little resistor, I'm going to rotate it. Resistors don't matter the direction they're in. Electricity can flow through them in either direction. So I'm going to use the resistor to kind of jump from this negative row. Okay, in essence, think I need to make a connection. I need to connect this wire to the resistor. Let's think of it that way. Okay, so if I'm going to connect this wire to this resistor, I need that point, one of the ends, to be connected to any one of these other little holes, and I've made a connection. Like that. It just so happens that when I placed it here, the other end is now in these little strips. Okay, this little strip of 5. So if I want to connect the resistor to something else, I just need to plug this something else into one of these 5 holes. Now that something else could be directly going to another component, or could even just be a wire. You know, I could have, if you wanted to use a wire, and I can zoom in. If I click on one of these holes, I'm going to make a connection, but I want to show you I can kind of click in the middle and kind of create bends. I'm going to kind of, and let's just make that a different color. Okay, so basically the path of electricity you can see so far in just making a loop, I've got a path that comes here, and that wire connects via this metal rail to the resistor. So these are connected, so electricity has a loop where it's able to flow through the resistor and into this metal strip. And then that metal strip, right, has this wire connected to it. So it's got a path where the electricity can find this metal wire and make it all the way over to here. But then it hits this metal strip and it's hit a dead end. It's got nowhere to go, right? There's nothing else plugged into that it can kind of keep going and continue to loop. So let's bring the LED on. Okay, and when I click the LED, you can change the color. Okay, you can give it a name. And then if you, an LED stands for a light emitting diode. Okay, light emitting diode. A diode is something that only allows electricity to flow in a single direction. So if we don't hook this up in the correct orientation, our light won't turn on. And so if we're not sure, we can always just kind of test it out. We can just, I'm going to go ahead and plug the LED. The 2 wires are really close together. So I'll just kind of plop it down like that. And you can see electricity, we kind of knew that it made its way through from this wire to this little strip, and now it's got a path to hit that wire and kind of go through the LED, but then it again hits a dead end here. So from here we have to complete a loop and get it to somehow make it back to that wire and back to our power supply. So I'm going to give electricity the opportunity to go from this set of, you know, this little metal strip from here back to that red wire, which is really connecting to any one of these. I'm going to make that red. Okay, and so now hopefully you can see the path, how electricity has a loop forming from this wire to the resistor, right? The black and the resistor, how are they connected? Because they are on the same strip. Notice nothing else is plugged into that strip. So that strip was used to connect the black wire to the resistor. And then the resistor was connected to the green wire via this strip. So that strip is acting as the connector. So going back to here, it's just that little metal strip is acting as one of these guys. Okay, and then this metal strip is connecting the green wire to the LED. That strip is connecting the LED, the other side of the LED, to the red wire. And then this strip down here is connecting this red wire to the other red wire. All right, so how do I know if it worked? Up here in the toolbar, there's a Start Simulation button I can press and click, and if it worked, I'm going to see the LED light up. Now, it is kind of letting me know that it's kind of a warning, the exclamation mark, that it thinks there's too much current flowing, and that in the real world I might burn out my LED with that much current. And so I can click on, I have to stop simulator to edit things, but I could come over here and I could up my resistance level, say from 250 to 350. Start the simulation again. Oh, it still thinks there's too much. There you go. I went up to 500 ohms of resistance, and now Tinkercad is no longer thinking I'm going to have any issues, and so the LED doesn't have the little warning next to it. And if I up the resistance a whole lot, let's just make that kilo ohms. The more resistance, we're restricting the flow of electricity. You'll see that Tinkercad is still, hopefully you can see that the light kind of turned on, but it doesn't turn on as bright. So they're trying to simulate that, hey, there's more resistance, there's less flow of electrons, and so the LED is not going to be as bright. And in the real world, it might be that we have so much resistance we wouldn't see our LEDs turn on at all. Okay, so there is our first basic circuit. And for day one, what I want you to do is to watch this video to make this basic, very basic circuit. I know I haven't used the multimeter yet, but we're going to get to it. To get the LED to turn on, and then you can use your snipping tool to take a snip, send me an email to let me know that you have made it this far, just to confirm, right? You've got that. And then day two, we'll kind of pick up from there. While I'm here, though, let's mention one thing. I'm going to pull the LED off. Okay, so on the LED, if you hover over these, you see cathode and anode. Okay, I paused the video to go prove, I just to give credit, I guess, where credit's due. I had another tab open where, I was looking for some kind of mnemonic, some device that would help you guys remember that cathode and anode, and I had come across this one. And thanks to megafarad, and farad you're probably not familiar with, but a farad is also a unit used in electricity. It's used to measure another electrical component called a capacitor. So there are things called capacitors, and they are measured in farads. So megafarad 5 years ago had posted to the web. He said, "Don't panic," just in a forum where people are asking, how do you remember this? And there's a whole lot of ideas of how people remember this. Some were not appropriate, some were, some didn't really jive with me and weren't simple enough. This one was really simple. So he said, don't panic. Panic meaning positive anode, negative is cathode. And so I'll share that with you if that's helpful. So let's close that. So the cathode, panic, right? Positive is anode, negative is cathode. So the anode is, where did I had it plugged in? We're here, right? Is connected to the red, which in our circuit is looping back to the, I don't think it highlights positive when you come over here, but it's back here to the red, which was the positive terminal. And then this one, the cathode, is pointing on the loop back to the other one, which this one will tell you is negative. So anyway, I hope that helps. Another thing that people do just physically to look at this and remember is that LEDs, and Tinkercad did this in their illustration. When you look at the two terminals, okay, the two terminals are generally not the same length. One is going to be a little longer and has a little bend to it, and so that's the anode. See how they've got like a little bend here? So that one's usually a little longer, and so that one's the one that goes to the positive side. And then the negative one is usually shorter and straight. The other thing is on that negative side, the LED, they look round, and especially in real life, they look round, and it's almost sometimes really subtle on the plastic. But on that plastic, instead of it being a perfect cylinder there, one side is just a little flat. It's almost if somebody hit it just to a sanding belt and just kind of just sanded just a small little spot and made just a teeny little flat spot on the plastic. Well, that flat spot is on the negative side as well. So when we have these in real life and you're trying to figure out, and I can't just hover a mouse over the tails, you know, these little we call them leads, the leads, to figure out which one's the positive and negative, that's how they're going to figure it out. Now the other thing you can do is you can try plugging it one way and seeing if it works, and if it works, you know you got it right. And if you got it backwards, which to simulate that, how about I just I could, let's see, I can rotate it another way. It won't turn on. So it's not going to really hurt the LED. It's just, it's like a one-way valve. It's not going to let electricity flow in that direction, and so your light's not going to turn on. So before you think your light bulb is a bad light bulb and doesn't work, try unplugging it from your breadboard, plugging it in the other direction, and starting the simulation. Okay? Alright, well, I hope that helps for day one to give you a little introduction to what a breadboard is and to what Tinkercad is and how we're going to start using this.